In today's lesson, we are looking at trigonometry application problems. So we're going to be looking at how to basically apply the right angle trig we've learned into some application problems. So the biggest thing here is going to be figuring out how to draw triangles based off of a given scenario. So some key terms we want to think of before, or we want to know before we start looking at these scenarios, are the angle of elevation and the angle of depression. Now, the angle of elevation is an angle formed from the horizontal and upwards to the line of sight. So what that means is if we have a horizontal line, our angle is going to be formed upwards to whatever our line of sight is. So that would be considered the angle of elevation, and our angle would be here. The angle of depression would be forming from the horizontal and going downwards to the line of sight. So you're looking down from the horizontal. So we're going down from our horizontal to our line of sight. This angle here, this would be considered the angle of depression. Right, so those are just some key terms we want to think of as we go into these scenarios. So problem 1. While walking to school, you pass a barn with a silo. Looking up to the top of the silo, you estimate the angle of elevation to the top to be about 14 degrees. You continue walking and find that you were around 40 meters from the silo when you calculated that angle of elevation. Using this information and your knowledge of trigonometric ratios, calculate the height of the silo. So again, because we're only dealing with the right-angled trig right now, we have to assume that we're going to have a right-angled triangle somewhere in this question. And hopefully from reading through it, you kind of see where that's going to be. Right, we have an angle of elevation that's 14 degrees. We're at 40 meters from the silo, and you're looking for the height of the silo. So a good thing with word problems or word scenarios is to reread the question. All right, think about what we're doing, or find any key information to help us. So if you reread it, that's okay. Then if you need to then underline or highlight key pieces of information, go right ahead. So let's just start off. Let's draw our silo here. Here's our silo. Maybe got a little door at the bottom. So there's our silo. We want to calculate the height. We know that when we were standing 40, that's not quite level. When we were standing 40 meters away, our angle of elevation to the top was 14 degrees. And again, we said it was 40 meters away, and we want to find the height. So now we have enough information to find the height because we have an angle, we have a side, and we're looking for another side. So again, we have our right angle triangle, assuming that the silo and the ground forms a right angle. Next step is to label our sides. So we have the angle we're using. The side across from it is the opposite. Beside it is adjacent, and then across from the 90 degrees is the hypotenuse. Again, the sides that we're dealing with are opposite and adjacent, so in this case, we need to be dealing with tan. So tan theta equals O over A. Tan of 14 is equal to an unknown over 40. And as we've said before in our previous lesson, the missing piece is on top, so the bottom comes up and multiplies. So 40 times tan of 14 will equal our unknown height. So this just becomes a one calculation. And we get 9.97 meters is equal to the height. So again, the math that we're going to be using is the same as what we've looked at before. The biggest thing now is that we have to draw our triangle from the scenario. Problem number 2. A sailboat is approaching a cliff. The angle of elevation from the sailboat to the top of the cliff is 35 degrees. The height of the cliff is known to be about 2,000 meters. How far is the sailboat away from the cliff, or from the base of the cliff? So again, let's draw our information. Right, so we can draw it. We have a cliff. The bottom of the cliff, we've got some water. In the water we have our sailboat. And then we can start adding in the information. Right, so we have to go back and read it. It's approaching the cliff. The angle of elevation to the top of the cliff is 35 degrees. So if I were to draw a line roughly going from the top of the cliff to my sailboat, that angle is 35 degrees. Draw a horizontal there. We know the height of the cliff is 2,000 meters, and we're looking for how far away is the sailboat from the base of the cliff. So we're looking for this x value down here. So again, we have all of our information, so let's go through and label our sides. Right, we have our angle, again assuming that the cliff and the horizontal distance make 90 degrees. We then can figure out our hypotenuse, which is across from the 90 degrees, based off of the angle we have here. We have two sides that we're dealing with. The x is the adjacent because it's beside our angle, and the 2,000 meters is the opposite because it's across from or opposite from our angle. With this information now, we can go and figure out, well, I'm dealing with O and A, so I'm going to be using tan again. So tan theta equals O over A. Tan of 35 is equal to 2,000 over x. And in this case, we have a different scenario with a variable on the bottom. And in this case, we said we're going to end up dividing. We're going to switch the tan 35 and the x and divide. We get x equals 2,000 divided by tan 35, which is 2,856.3 meters. So that is how far away from the cliff the boat is. So the boat is about 2.8 kilometers away. Last question. A sailboat is 2 kilometers due west of a lighthouse, or a sailboat that is 2 kilometers due west of a lighthouse sends a signal to the lighthouse that it is in distress. The lighthouse quickly signals a rescue plane that is 7 kilometers due south of the lighthouse. What heading from due north should the plane take in order to intercept the troubled sailboat? So we have our sailboat, and it is 2 kilometers due west. So let's draw our sailboat, right? So let's say our sailboat is sinking. Oops. It's in this distress. So our sailboat, we have kind of the cracked mast. There in the water. Calling for help. So this sailboat is 2 kilometers due west. So that means 2 kilometers, and then we can highlight this as well. So 2 kilometers due west of the lighthouse. So we can draw in our lighthouse here. And sometimes it's nice to have a nice drawing. Sure, this looks like a lighthouse. So we have our lighthouse, and then that lighthouse sends a signal to a rescue plane that is 7 kilometers due south. So 7 kilometers south of our lighthouse. So we can start to see our triangle being formed. And obviously, even though we can see the angles on the ruler, don't assume that everything is to scale. And then we have our plane. Down here at the bottom, and we want to figure out at what angle due north or from north should our plane be flying at in order to head to the sailboat. So we have all the information we need. We have 2 sides, we have an angle that we're missing, so we can start to label. Right across from the angle is the opposite, across from the 90 degrees is the hypotenuse, and besides the angle, or beside the angle, is the adjacent. So we know the 7 kilometers due south. We want to know what heading from due north the plane should take, or what that angle is. So we're dealing with the opposite and the adjacent. Those are the only 2 sides we have. So again, we are dealing with tan. So tan opposite over adjacent. We can plug in all our information. So 2 over 7. And again, anytime we're trying to find an angle, we use the inverse. So tan negative 1 of 2 divided by 7. And we get an angle of 15.95, or we can say we'll round it to 16 degrees. So that means that our plane should be flying 16 degrees west from north, or west of north. So basically, we look at north, we go 16 degrees west. That's the heading our plane should be flying in order to reach our sailboat. So again, just 3 quick questions using the trig, the different scenarios of the trig ratios that we've looked at in the previous lesson. The biggest thing here is just, again, reading the question and being able to draw our right angle triangle for that specific scenario. Once we have our triangle drawn, hopefully we've labeled everything correctly, then we go through the steps that we've looked at in the previous lesson to solve. Label the sides, find the ratio, determine what scenario we're dealing with, and then solve for the missing side or the angle. Again, the biggest thing is just finding the key information from the question and then being able to put that into our triangle. The nice thing is right now all we're dealing with is right angle triangles, so you know that's kind of what your image should be taking when you draw it out.